Hi, geometry students. So we're doing the final product of Can You Hear Me Now lab. So here we go. Last week, you guys did the points of concurrency worksheet. So you're going to want to make sure you remember how to do that. So an old telephone tower provides only a small area of surface coverage. Your cell phone company is planning to tear it down and build a new one that will provide better coverage. If you want to provide coverage to Detroit, Southfield, and Sterling Heights, where would you build the tower? If you remember back on your worksheet, the circumcenter is equidistant from the angles, okay? And that's really where you want that tower to be. You want it to be, so that it's equidistant from all those cities. And right now, they're saying that the actual tower is located in the in-center on the map. And it says, where is that? So we're going to remember how to do in-center. So the in-center, if you remember from your worksheet, was where the angle bisectors of the triangles meet, or the triangle meets. So all those angle bisectors. We're going to use a protractor, and all we need really is a protractor and a ruler, or you can just use the protractor as a ruler on the flat surface. So we'll do that to start. So we're going to find the angle bisectors. So I'm going to start down here with Detroit. And if I line up, I'll just look on, I guess if I turn it this way, I can line up my line, my protractor here, on the angle, really, so that it's going through this line where it says 0, and the tip of the angle is going through the center of this protractor right there. So if I look at this angle, it looks like it's about 47 degrees. Okay, so this angle right here is approximately 47 degrees. So what would be half of 47? Well, it would be 23 and a half. Half of 40 is 20, half of 7 is 3 and a half. So an angle bisector would mean to split it in half. So again, if I look on here, I need to split this thing in half. I need to go to 23, and again, I'm just going to be as accurate as I can be. So 23 and a half is about right there. So what I can do is I can draw a line splitting this angle in half like that. Okay? So there, I just split that angle in half. Now I got to do that again for all these other angles. Okay, so again, I'm going to line my protractor up on this angle for Sterling Heights, and I need to line it up so that the protractor is going through the 0 line here, and I'm hitting the angle. So now if I look at this, this looks like around 49 degrees, approximately 49 degrees. So, and again, hopefully we'll be pretty accurate. So half of 49 degrees is 24 and a half. So now I just have to measure out 24 and a half. Okay, so that's right about here, because there's 25. So right about there is 24 and a half. So if I do that, starting at the vertex here, or the vertex, and there's that. And then here's the last one. So this is what you're going to want to have, on your worksheet. So on here, line it up, okay? And again, this is nice. It looks like it's right at 85 degrees. That's kind of nice. So hopefully, again, these may not all add up to 180. It just depends on how accurate we were. And it doesn't look like it does, so this might be closer. According to this, 49 and 47 they actually, again, they add up to, was it 96? So really, if I took 49 and 47, that's 96. If I did 180 minus 96, 84 should be what this last angle should be, and it's pretty close. It looks like it's 85, but we can say it's 84 degrees. Half of that would be 42. So you just have to measure out 42, and that's right about here. Okay, so I went to the 40 and then out to the 2. And again, this will be, you know, it's going to be kind of close. The reason it's not going to be super close, I guess, is because of, you know, my error. But it should go right through this point right here. Okay, that's where it should be. So it should be here in the center. That should be your in-center. Again, you just have to kind of do it as accurately as possible. But yeah, if you bisect all of these angles nicely, you should get the in-center here. It's not perfect, but so old tower is what you want to label that. Okay? And so you can kind of see it's not really equidistant from the angles. Like if you look here from the vertex, each of the vertices, this is a lot longer than this right here. Okay? And then this one's even longer than this one. So this isn't really a fair setup. Detroit's the farthest from this tower, and then Sterling Heights is the second farthest, and then Southfield's the third. So again, it's not really a fair setup. So what they wanted to do is they wanted to construct a new tower that would be the Circumcenter. And again, that is found by doing the perpendicular bisectors. So for that, we actually need a ruler. So for this one, remember, we'll use centimeters. So if you look at the distance from Detroit to Sterling Heights, that's 11. Okay, it's nice that it's actually pretty much right on the 11. So a halfway would be 5.5. So I'm just going to mark 5.5. So there's my my one right there. And then what I have to do is use my protractor. Perpendicular bisector means that it goes through that halfway point, but it goes at a 90-degree angle to this line here. So I'm just going to mark where the 90-degree line is, and I'm just going to draw my line straight up and down. So there we go. There is one of the perpendicular bisectors. Okay, we'll do it again. Let's measure from Sterling Heights to Southfield. So again, for this one, oh look, it looks like it's about 8. Halfway would be 4. At least that's a little bit nicer. So 4. And then, again, use your protractor. So going through that right there, that's where 4 is. Make sure you're lined up on the side. 90 degrees would be right here. So you're going to mark the 90-degree angle, and then draw your line, going through the bisector and the mark that you made for 90 degrees. And then the final one here, okay, this looks like maybe around 8 and 4 tick marks. So we'll do 4 and 2 tick marks. That would be like the halfway point. So right about in here, it's a little bit less, but yeah, it looks like about 8 and 4. So I'm just going to do around 4 and 2. Okay, and then if I go at this point here, and I mark a 90-degree angle. Again, this isn't like, it's not always perfect just because of user error, but it should be about there. All right. So that went through better than the last one. So I'm just going to mark that. Oh, turning around. Huh. So here is the new tower. Right here. Oops. New tower. All right. And so that's called the circumcenter. And every one of these is at a right angle to the side, and they also bisect the sides. And notice too, if you look at the distance from this point, if you were to like look at the distance from here to here, it would be the same. Let's measure it. So let's see. The distance from the in-center to Sterling Heights is about 5.5. Okay, so we should expect the other ones to be really close to that. So again, the distance, look at that. From here to Southfield, it's 5.5. I'm looking at the in-center, or the circumcenter, all the way up to the vertex. It's also 5.5. And then this one should also be 5.5. And look at that, 5.5. So these are all equidistant from the vertex, which is really nice. So that's going to be a lot more fair if the tower is equidistant. Okay? If the tower is the same distance away, that'll be a lot more fair for every city. So that's what they were trying to do. So that's the new tower. Final part is one of your friends lives east of the new tower, and he's worried about roaming charges and wants to check if his house is on the circle of coverage. So if I were to draw a circle connecting these points right here, if I drew a circle, okay, all the way around, basically using the vertex, going around to this one, and going around to this one, and then coming right back around, I'd have this large circle right here, okay? So it's saying he knows the angle made by Detroit, his house, and Sterling Heights is 84 degrees. Okay, so Detroit, which is here, his house, and Sterling Heights, which is up here, that's interesting. Okay, so he knows that the angle made by those three things, if I guess wherever his house is in here, he's saying that the angle, he's maybe over here. Oh, sorry, he's maybe over here. So it's saying the angle from here to here is 84 degrees. So it's saying somewhere over here there's an angle, okay, of 84 degrees. And you know that the angle between Detroit, Southfield, and Sterling Heights, so this angle right here, they're saying this angle right here is 96 degrees, okay? What's the sum of the measures of those two angles? Well, what's 84 plus 96? 180, okay? The three cities and your friend's house form a quadrilateral. The two angles mentioned are opposite angles. So we're saying that those two angles, this 84 degree one over here and the 96, they're opposite angles. If you can prove that quadrilaterals have all 4 points on a circle, let me read that again. If you can prove that quadrilaterals that have, there we go, all 4 points on a circle have opposite angles that are supplementary, then you'll know that your friend's house is on the coverage circle. Okay, so I'm just going to think this through here. You can also do this with me because I'll probably have to work this through with you here. But I'm just trying to find approximately 84 degrees here. Just going to give just moving this protractor along to see where he's going to be. So let's say if this is 84, well, actually, no, this is not. If we're looking at this is 84 right here. We're going from 0 on this side. But I really want to go from this angle here, so let me just try this. So 84 degrees. Let's do this. Might be better if I do it like this. Actually, let me pause this, and then we'll do it together in the class.